From what I can tell, those of us that are putting in the work are getting it, or have already gotten it.
I think I'm not getting it.
Well then, let's go over it. Take it. So you went ahead.
So x plus 7, right? This plus 4.
That's what we're okay. That's what. So you were working ahead. That's fine. All right. So let's all talk about it. Hey, 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 hey. Up here. All right. So here's the thing. I know that it may have been hard to see some of the lines, but it was -3, 1. So -3, 1. And then it was 4, 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Whatever way you went, okay, what was the rise?
4.
So +4. And the run? +7. And so here's the thing I want you to understand. What I would do if I'm calculating slope and learning new strategies, I would probably do it more than one way to check myself. You're comfortable with graphing. You're learning with the table. But we can see it here, all right? And I will say, I think it was Ari who did not like this mentally, but here's the thing I want you to see. What we're doing is we're going from -3 to 4. And so Ari, what were you initially thinking we were doing? How much did you think we were adding? Right, because 3 plus 1 is 4, right? But look, and this might help you visually. Whoops. Notice, I'm starting at -3. How far is it from -3 to 0? That's +3, isn't it? How far is it from 0 to 4?
4.
Does that help you already see it a little bit better? Just picturing stuff on a number line is super useful. Alright, so how much total are we adding to our x?
7.
+7. So our change in x, literally is how much x changed by, is 7. What is our change in y? 4. Please notice how I'm doing +7 and +4, because we are adding, we are not subtracting or doing anything like that. Just flip it upside down so you're not being distracted. We cannot be on our phones. There you go. Okay. So if I want my slope, we can see it as rise divided by run. So rise divided by run, which is 4/7. Or we can see it as the change in what? Y divided by the change in x, which is 4 divided by 7. Any questions about that?
Instead of doing this, why we just like rise and run?
It depends, right? Well, you can do either one. There's a reason why we're doing this, and it's what I'm about to look at with you in just a second. Okay? So, I need everyone's attention on this. I'm going to make that bigger because that is hard to see. Is that fair to say? It's hard to see what's on the board right now? Is that easier to see? Okay? So, here's what I want you to see. There is a thing known as, hey, Rose, up here, Jalen, up here. There is a thing known as a slope formula. Please hear me very clearly on this. I am teaching you the slope formula because I have to. I personally don't ever use a slope formula. This, right here, this is all I need to calculate the slope anytime, anywhere. The slope formula is cool. It's unnecessarily complicated, though. So, what I would do if I were you is I would learn rise divided by run, and I would do change in y divided by change in x. If you can identify those two things, you're golden, okay? But there is, as I said, there is a slope formula. Please make these notes on your paper. You see how here's some generic x1, y1? Do we know what those are? No, it's just a point. We good with that idea? Then we have a second point, x2, y2. We good with that?
Yeah, that's square.
Okay? There is, no, sub 2, not squared. Square is a exponent.
What's up to?
It just means x sub 1 means it's the x value of the first point, y value of the first point, x value of the second point, y value of the second point. I want y'all to look up here though, thinking about these points, Anyone know what the coordinates of this point would be?
3.
Think about it in respect to this.
3.
It's not a 3.
Is it a number?
Nope, it's a variable. Does this point have the same x as this point or this point?
I can't.
8.
I don't know.
0.8.
When you say point 8, you mean this one?
X1
Look,
and Y2.
you see how this is in line with this point, so it hasn't gone left or right, so this is x1 right here.
And Y2.
And then this has the same y value as this one,
So Y2.
so y2. That point right there is x1 comma y2. We go with that idea?
No.
Why not? You see how it's in line with this point? It's vertically, you see how it goes up, but does it go left or right?
Well, again.
From this point? Okay, right? It does not go left to right, so it's the same as this x value. And it is vertically the same as this value, this point. That's why it's y2.
Okay.
Now, here's something I do want you to notice. If I were to ask you, how far is it from 2 to 15? How far is it from 2 to 15? How'd you get that?
I don't see 13.
A lot of us would do 15 minus 2, right? If you didn't, it's okay. Maybe you added 13. But the reason I bring it up is, if I want to know how far these 2 points are away from each other, my rise, the change in y, I can do y2 minus y1. If I take this y value and I subtract this y value, that's going to give me my rise. Okay? If I just take the y values and I subtract them, that gives me my rise. So what am I going to do over here to get my run? X, not x1,
X squared.
x2.
X2 minus X1.
So my rise was y2 minus y1. My run was x2 minus x1. Man, I'm struggling.
Oh my gosh.
There we go. All right, rise and run. Notice how they define it right here. The change in y. How do we calculate the change in y? You can look on your sheet.
Delta Y is equal to Y2 minus
Delta y is equal to y2 minus y1. Isn't that what we just said? That's the rise? Then what's the run?
Delta X equals X2 minus X1.
All that being said, we now get that the slope is equal to rise divided by run. We can also say that slope is equal to delta y divided by delta x. And then we can also now say that it's y2 minus y1 divided by x2 minus x1. Notice that's just a way to say change in y divided by change in x.
Can that ever be 2 deltas?
Delta and delta.
No, man. 2 on the same place.
Yes.
Like this.
That's actually a really good question, and yes, that is not something we would ever touch.
What?
Okay. These are just different ways to calculate slope. What did I say I would recommend?
Delta.
Rise divided by run, or delta y divided by delta x. That's how I personally am going to do it every single time.
What's easy?
The 2 I just said.
Alright.
Okay? And here is an example of using each of those 3. Okay? So let's look at this together. Graphing, it's already given to us. What's my change in y? Anybody? Change in y is? Remember, change in y, that's my rise. So I'm looking at the y value, minus 9. What's the change in x? Okay, change in the x. So we get negative 9 11ths.
Not really.
Negative 9 11ths divided by 11.
Can it also be 11 divided by negative 9?
No. It could be, hold on, it could be a positive 9 divided by negative 11. But remember, what does the change in y have to be? The change in y has to be a 9. Either going up 9 or down 9. Well, Kelsey, hey look, right here. So you said 11 divided by negative 9, right? So if I start here, I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you do, is that the same line? So can we do 11 divided by negative 9?
No.
No. Then 9 has to be the change in y. Okay? Alright. Now, again in the table, to go from 6 to negative 3, what are we doing? Subtracting how much? 9, yeah. Because how far is 6 from 0? 6. How far is 0 from negative 3? So 6 plus 3 is 9. I'm just subtracting that 9. To go from negative 4 to 7, I am adding 11. So I again have my delta y. That's y values, right? This is delta x. So negative 9 divided by 11. This is why I recommend using one of those two. See how we have coordinate points right here? First off, can you take those coordinate points and just quickly put them in a table?
No. Oh, yeah.
Yeah, that's literally negative 4, 6, right? And 7, negative 3. In order to use this formula, what is y2? It's the negative 3. What is the y1?
6.
And then x2?
7.
7. Minus x1? Negative. But even right already, are you starting to mix up which one is which? Yes. Right? This is why I don't love this version of the slope formula. It works. What is negative 3 minus 6? Negative 9. What is 7 minus a negative 4? 11.
I don't like that.
Same. You do, wait, did you say you do or don't? I don't either, right? I would rather do change in y and change in x. It is so much easier for me to just go, hey, 6 minus 9 is negative 3. That's my change in y. Negative 4 plus 11 is 7. That's my change in x. But here's the thing. If you like this, can you do it?
Yeah.
Yes. We all good with this? Yes, sir. Huh? I'm teaching. Hold on. So, here's what I'm going to ask you to do so that you can get some practice with it tonight. Can you do the last problem on that page? Just on your own, tonight for homework, the graph, the table, and using the slope formula. Should you get the same answer for all three of those?
No.
Yes. Okay? So, tonight for homework, you got the you try here. Just do those three on your own. We'll talk about it if you have questions tomorrow. Sound good?
What's the homework that's due on Friday?
We don't have, the homework due on Friday is the segment addition one, which is on the back side of the angle sheet, and you'll have a chance to ask questions about it tomorrow. It's not that sheet.
Wait, is it the back of the sheet and the back of the sheet?
No, it's just the back. It's just where it says exploring angle pairs.
Oh.
That's what it was. It wasn't second edition. It was exploring angle pairs.
What?
Terrence, I can't play. What? Yes.
We gave it to us yesterday.
It's on the back.
I was asking what time.
He called live.
Try it at home tonight. You should. Hey guys, again, I'm just asking you to try that those bottom three. Should you get the same slope across? Yes. Okay, so you try it on your own, you'll get the same slope across. Here is the last thing that we need to learn. Okay? Here's the last thing that we need to learn, and it is called the distance formula.
Okay.
Hopefully we recognize a couple of these terms up here. Anybody? Pythagorean Theorem. Did y'all learn that in middle school?
Yes, we did.
Okay? For someone, hey, listen. For someone who remembers the Pythagorean Theorem, what did y'all learn?
We learned
Square plus B squared equals
C
Always
squared equals C squared.
Do we recognize it now?
Yes, sir.
Okay? When we say a squared plus b squared equals c squared, what are we referring to? What's the hypotenuse?
The hypotenuse is
Squared is the hypotenuse?
what's the slope?
It's the longest line.
Okay, so C is the longest side of a what?
Triangle.
What type of triangle?
Isosceles line.
Not isosceles. Which one?
Right triangle.
A right triangle. Okay? The Pythagorean Theorem, please write this down on the as the crow flies sheet. The Pythagorean Theorem only works for what type of triangle? Okay. The Pythagorean Theorem works for a right triangle. That's the only thing that it works for. So where does the C come from?
That's the
From the longest side.
distance in between.
It is the, which one?
Longest side of the triangle.
Okay, it is the longest side of the triangle, which is where?
Top.
I mean, top.
But most importantly, I need y'all to hear me on this, because a hypotenuse is not just the longest side of a triangle. It is the side that is opposite
From the right angle.
from the right angle. The right angle is the biggest angle, so the side opposite is going to be the biggest side. The reason why I say it's the side opposite the biggest angle is because do I have a hypotenuse in a triangle like this?
No.
Because it has to be across from what kind of angle?
Alright.
A right angle. Okay? So you can't have a hypotenuse and an obtuse angle. So it's not just, hey, it's the biggest side in general, it is the biggest side that is opposite a right angle. Does it matter where the A and B go from here? Nope, just A and B. We all good with that?
Yeah.
So that's important for what we're about to look at. So we're going to learn about the distance formula, and we're also going to talk about the midpoint, which we already talked about that a little bit. Okay? So looking at this task sheet, you have this scenario of the city in which you live has a system of evenly spaced perpendicular streets, forming square city blocks. The map shows your school, your house, which is located 2 blocks west and 5 blocks north of the school, and Amy's house, which is located 8 blocks east and 1 block south of the school. Alright, so we see all this here, correct?
Yeah.
Working within your groups, do number 1, how many blocks would you have to drive, right? How many blocks would you have to drive, so you have to go along the roads, right? To get to Amy's house from your house. Number 2, what if you could use a helicopter to fly straight there? So work with your group to figure out the answers to numbers 1 and 2. Hey, really quickly, don't just count. Draw the path. Draw the path. Trust me, it matters for learning what we're supposed to learn. So draw the path that you're going to take.
So would you go down?
10.
So remember, don't just tell each other, discuss it. Say it again.
No.
That's a good question. Can you go across to the right and then down?
Oh,
Huh?
I did it too.
As long as there's road there, so you could go either of those ways.
You
That's
made it
important.
weird.
I got 16.
How did she make it different? It looks exactly the same.
Oh, it was different before. Yeah, like that. I don't know what I was getting at.
You little slow.
What are you doing right here? What's that?
I got 16.
That's the what?
You got 16?
That's what?
I got 14, man.
What does it ask for? How many blocks do you have to drive? So you're saying you drive 6 here? And then how many here? So how many blocks is that?
You're not counting the boxes, you're doing the lines.
Negative 10 more.